All right, good morning, good afternoon, good evening, whenever you're watching this video. I hope you're doing great. I'm about to walk you through the distance formula. Now, some of you may have actually dabbled in the distance formula a little bit in previous years, but I really want to get into why it is, what it is, and make sure we understand that. So before we do that, we actually want to get into the coordinate plane because we're going to be using that quite a bit. and I really hope that my tools work better than what they just did a little bit ago. I had to restart my video because they just were overly touchy. So maybe it's how I was using them. I'm going to try to use them a little bit different manner. But if this doesn't come out real clear, just know that it's still got better penmanship than some of you. Anyways, here's what we're going to do. Starting off with the axes, the horizontal axis here is going to be our x-axis. So I'm not even touching the board and it's already drawing for me. There's my x-axis. This one right here, the vertical axis, we consider that the y-axis. Okay? And from there, if I move to the right of my origin, then it's going to be considered a positive motion. Most of us are right-handed. Going to the right is a good thing. Moving to the left of the origin would be a negative motion. Okay, so negative. Okay. Going above or up is a positive thing. If your grade is ascending, meaning it's going up, that's a positive thing. If it's going down, that's a negative thing. We don't want our parents to know that we're not doing so good in school. All right. Now, from there, we also want to list the different quadrants. Okay, if you remember, okay, which one's the first, second, third, and fourth? Very simply, the upper right-hand corner is considered the first quadrant. Okay. The upper left is considered the second quadrant. Lower left is considered the third quadrant. And then the lower right is considered the fourth quadrant. Now, I don't know if you've ever asked the question as to why, but when you get into Algebra 2, they will explain why. When they're talking about radians, a lot of times they will start right here on what they consider the 0, and they will move in a counterclockwise motion about the origin there. And so you want to start in the first quadrant, move to your second, third, and then fourth. Okay? Now from there, within the coordinate plane, we have our ordered pairs or our coordinates. Okay, so let's go ahead and make a little note of that. Coordinates. Okay? And we all know our coordinates are listed x, then y. Okay? If you ever struggle with, okay, which is first, horizontal or vertical, if you can remember that x is horizontal and y is vertical, the ordered pairs or the coordinates always come in alphabetical order. Okay, so x, then y. Now, for the, another name I could use for coordinates would be ordered pairs. So I'm just going to put down here in quotations, ordered pairs. Okay. That's another name that I could use to describe what's happening there. Now, from there, I'm going to try to keep this as clean as possible, folks. I apologize. I don't know why it's so extremely sensitive. I'm going to clear that off there. From here, I'm going to list 2 points. One is going to be B at negative 3, 1. So here is B at negative 3, 1. So I'm going to make it nice and large so it's not so sloppy. Negative 3, comma 1. Okay? And then the other point is going to be at A at 7, 5. So if I go over 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 7, 5, that point right there, okay, is going to be A at 7, 5. Okay, 7, 5. Now, I'd like to be able to find the distance between those 2 points. And there's several ways you can do that. But before we find the distance between A and B, let's go ahead and put point C up here, which is going to be at negative 3, 5. So negative 3, 1, 2, 3, 4, 5, right there. Okay? So C is at negative 3, comma 5. All right. So from there, I can actually ask you guys, I hope you can figure this out, what the distance is from B to C. And if we count this, 1, 2, 3, 4, we always start at 0. So 1, 2, 3, 4. That would be the distance from B to C, okay? Now, if I count the distance from A to C, count that distance, again, starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a distance of 10 from A to C, all right? So then the question becomes, can we count the distance from A to B? And the answer is no, okay? If you think about this distance here, down here at the bottom, okay, that distance there, and that distance there, if I were to go ahead and say that this is a string, and I've got let's say a yo-yo out here, and I was to swing it, that yo-yo would go something like this, okay, a curve right there. All right, the distance diagonally on a coordinate plane is longer than the distance vertically or horizontally. And so as a result, we have to get creative on how we're going to figure out those distances. So how do we do that? Well, one way would be to go ahead and use your Pythagorean theorem. So let's write that out. Pythagorean theorem. Okay, and I'm going to encourage you to write kind of small here as you do that because I've got a lot of notes for you to take. So, and it looks like I'm writing cursive up there. I'm really not. It's just the board is that sensitive and it's reading that I'm doing something I'm not. So, all right, so what is the Pythagorean theorem? I think most of you have probably used it in the past, but here's what it is. You know it to be a squared plus b squared is equal to c squared. That's awful. I can't stand my sloppiness. So a squared plus b squared is equal to c squared. All right, now, as of right now, a, b, and c would be these sides right here, okay? I'm going to see if I can minimize that so I can have more space. Oh, I can't. Can I minimize it there? There we go, sweet. All right. So what are A and B? Well, A and B would be considered the legs, so this would be a leg, and this would be considered a leg. Hey, it's actually more precise when I write cursive, interesting. And C would be the hypotenuse. Now the hypotenuse, I need you guys to go ahead and understand where it's always going to be located. The hypotenuse is always across from the right angle. Okay? It's always the longest side of the right triangle. And so one of those two ways, if you remember the longest side or it's across from the right angle, it doesn't matter to me, but you understand that C is always the hypotenuse. The legs can interchange. A and B can switch spots, but C has to remain on the other side of the equal sign. So one thing I'd almost encourage you guys to start to do when we talk about this is to think of the Pythagorean theorem instead of a squared plus b squared equals c squared. I mean, what's a, b, and c is actually to describe it as leg squared. Sorry, trying to write and think at the same time. Leg squared plus leg squared equals hypotenuse squared. Okay. Now, if I go ahead and take this information and apply it to what I have over here on my graph, I've got 4 as a leg and 10 as a leg. So I can go ahead and plug those in. 4 squared plus 10 squared is equal to the length of AB squared, the hypotenuse squared. Okay? So from there, we just have to work things out, order of operations. Okay? So what's the order of operations say first? Well, it says to square. Okay? So I'm going to square things. Use the exponent. So 16 plus 100 is equal to AB squared. Okay? Then it says to go ahead and combine like terms. So I'm going to go ahead and, or to add. So I'm going to go ahead and take 116 is equal to AB squared. Now I want to get AB by itself. And I know you guys talked about this a little bit last year, but how do you undo a square? Well, you undo a square by doing the square root. So you can go ahead and square root that, and they will cancel each other out. Okay? So we get the square root of 116 is equal to the length of AB. Now, at this point in time, you can go ahead and plug that into your calculator, and you're going to get approximately 10.8. So I'll just jot that down right here. 10.8 10.8. All right. But you know, I really don't like approximately. I want to be as exact as possible. So what we're going to do is we're going to do what's called simplifying the radical. Now, if what I'm going to do over the next couple of minutes here doesn't make sense to you, continue to practice it, try to figure it out, because you're going to see it in the second semester, and we're going to hit it really hard then. And so if you don't understand it, come second semester, you're going to have to understand it. So it's always good to practice things before we're really tested upon them. So from here, if I go ahead and ask myself what number goes into 116 evenly, I would think, well, 2, because it's an even number. So I go ahead and divide 116 by 2, and I get 58. Oh, hey, 58's an even number. So I'm going to divide 58 by 2. Okay? And I get 29. Now 29 is prime, so I'm going to leave it just like that. And I figured out the factors of 116. Now you guys, I'm pretty sure you guys know that the square root of 4 is 2. And why is that? Well, 4 is a perfect square. When I go ahead and work it out, 2 times 2 is 4, and now it can come out from underneath that radical to be just the answer that we put up there. Okay? So whenever you have a duplicate underneath the radical, you can pull that out, and my answer here is 2, and I leave the 29 underneath that radical still. I don't bring it out. Okay? And I'd encourage you to type that in your calculator, 2 radical 29. And what you're going to notice is you're going to get that 10.8, all right? But here's the deal. That 10.8 stops after the 8. The 2 radical 29 has all the digits that you didn't keep up there, okay? So 2 radical 29 is what I'd like to see. All right, now, you may be thinking to yourself, I thought we were going to be talking about the distance formula today. Well, the Pythagorean theorem is a form of the distance formula. Here's what I want you to see next. Keep all those notes there, and I'm going to erase. Oh, I don't want to do that. I'm going to erase. Oh, come back, please. Pin it there. All right. Where's my erase? There it is. My eraser's there. Going to make her nice and big, if I can. There we go. Okay. And I'm going to get rid of this stuff. Now, again, remember what we had there. We had the square root of 116, and that'll be the quickest way to show what we're doing, but 2 radical 29 is our answer there. So where does this distance formula come into play? Well, one of the things I want you to see is that if I go ahead and take this x value here, 7, and I subtract -3, I'm going to get 10. So I'm going to write this out. 7 minus -3. Okay, that actually equals the -10. And if you look at let's see here. Yeah. If you look at the 4, if I take 5 minus 1, I get 4. All right? So how does this all play out? How does the distance formula come into play? Well, I'm going to go ahead and label these points. I'm going to label this one x sub 1, so 1 down below, and y sub 1 as my ordered pair. And this one's going to be x sub 2, nice 2, and y sub 2. Okay? And so if I plug in these values here, this 7 was x sub 2 minus the -3, if I look down here, okay, is actually x sub 1. Okay, that's a 1 there. All right? And over here, the 5 minus 1, the 5 is, I can look at A, that's the y sub 2. And the 1 is actually y sub 1, so minus y sub 1, okay? So again, our Pythagorean theorem, which was this, right, Well, I can plug in those leg lengths, x sub 2 minus x sub 1 squared. So that would be a squared. That would be this leg over here, okay, where the 10 is. That would be that squared. Plus, for the other leg, I'm going to do y sub 2 minus y sub 1 squared. Okay, so we've got both legs squared is equal to the hypotenuse squared. Well, that was AB squared. Now, let's do the distance formula. So I'm going to say the distance squared. Okay? Now, from there, I'm going to leave everything on the left the way it is, but this distance squared over here, I want just the distance by itself. So I'm going to go ahead and square root to get rid of that, to undo that square. I'm going to square root this side, and that's your distance formula. I'm going to try to write out a little more clearly here for you. The distance formula will always be the square root of parentheses x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? Now you may still be skeptical, like, I don't know about all this stuff. Well, let's prove it. Let's go back to our answer here. We said it was the square root of 116, which becomes 2 radical 29. And I'm going to plug in all this information here just from the coordinates. So from the coordinates, I'm going to look at x sub 2, which we said was 7. X sub 1, which we said was negative 3. Okay, well that looks familiar. Okay, 7 minus negative 3. Plus y sub 2, which is going to be 5, minus y sub 1, which was 1. Okay, squared. Try to make that better. Squared. Okay. Now, if we work this out, the double negative, as my pre-algebra students like to say, is the drunken plus sign. Okay. So from there, we have 7 plus 3, which is 10. And 5 minus 1, which is 4. Okay. And so we end up with 100 plus 16. Oh, there's your 116, the square root of 116. Okay. So again, you have your distance formula, you have your Pythagorean theorem. Do I really care which equation you use? The answer is no. You can use either one. Okay. Now, one question that usually comes up, well, let me go back to that. You can use either the distance formula or the Pythagorean theorem, but it is definitely easier to use the distance formula when it's graphed, when the coordinates are graphed. It is definitely easier to use the distance formula when the coordinates are not graphed. Okay? Do I expect you to know how to do both of them? And the answer is yes. Okay? So make sure that you know how to use both of these formulas. Now, I always have a question from a student that says, okay, what if I switch these two? X sub, the x sub 1 and y sub 1, what if I make them x sub 2 and make these other ones at A the x sub 1s? Well, let's go ahead and look at that. Let me go ahead and clear some space for us to operate. Okay. All right, so if I were to switch those two, now B is the x sub 2, so, all right, so x sub 2 in this case would be negative 3, minus x sub 1, which would be 7 squared, plus x or y sub 2 would be 1 minus y sub 2, which would be 5. Okay, again, that's squared. Now, as we work this out, what's negative 3 minus 7? Well, that's negative 10. Ooh, should I be concerned? Well, we'll talk about that in a second. 1 minus 5 is negative 4. Oh boy. I definitely probably made a mistake. Well, let's see. Okay, now, I keep those in parentheses, and here's why. I'm not only squaring the 10, I'm squaring that negative. So when I take negative 10 times negative 10, That's positive 100. Oh, now I'm starting to feel a little bit better about what I'm doing. Okay, negative 4 times negative 4 gets 16. Okay, and there's your square root of 116, which ends up being the 2 radical 29 that we talked about earlier. All right, very good. For the next thing that I want to do, I want you to practice this for me. Okay, so I'm going to give you one more example. Actually, I'm going to clear all of this off. If any of that didn't make sense, go back and take a look at it. Re-listen to it. Can I go down? Yeah, there we go. Scroll down. Oh, back up, please. Example 2. Example 2. There we go. Okay. So here's what I want to do for example 2. I'm going to give you 2 points, and I want you to use both the Pythagorean theorem and the distance formula for this one. Okay. So do it twice, and just make sure that you know how to execute these. So the points that I'd like you to graph and use, A will be at negative 5, 6, and B will be at 3, negative 2. Okay? Now, I want you to graph these, okay? And you can use either, I want you to use both of them, the Pythagorean theorem and the distance formula. I'd like you to pause your computer right now, and I'd like you to do this on your own, okay? Really challenge yourself, see if you can do all that on your own. If you get stuck, press play, and I'm here. I'm going to show you how to do it in a little bit. But give yourself a chance to try it on your own. You never can fully do something on your own until you take that step of ownership, okay? I think we all know this. I was actually working with a buddy of mine this last summer who built his very first pole barn. He's a contractor and he usually works under another guy. And he had all these headaches that he came up with. And I told him as he was getting frustrated, I just said, hey, you know what? You're better off by trying this and learning these headaches. This is the learning curve right now. And it's not fun, but you know what? You're better off than if you would just stay under that other guy the whole time, because when you take ownership of something, you really learn it a lot better, all right? And in most situations, you get paid a lot better too, okay? So anyways, pause your computer, please, and give it a shot. All right, well, hopefully you were successful. You gave it a good shot. I'm actually going to go ahead and start laying this stuff out. Negative 5, so 1, 2, 3, 4, 5, positive 6, 1, 2, 3, 4, 5, 6. Okay, so A is right there. B is going to be at 3, negative 2, so 1, 2, 3, 1, 2. B is right there. Okay, and we want to figure out the distance between those. Since I'm graphing it, I'm going to use the Pythagorean theorem first. So I'm going to go ahead and connect this, form a right triangle. Usually students have a question, does it matter if the triangle is below the line or above the line? The answer is no. The only thing that matters is that it's a right triangle. Okay. So when I count the distance of the bottom leg, I've got 1, 2, 3, 4, 5, 6, 7, 8. A length of 8. Okay, so again, make sure you're starting at 0 and counting one direction or the other, but it's a length of 8. 1, 2, 3, 4, 5, 6, 7, 8. The vertical distance is 8 as well. Okay, interesting. What do we call this type of right triangle? Well, I hope you're thinking in your head isosceles, because if you know that, then you're going to be a leg up on when we get into the triangles. And almost everything in geometry comes back to triangles, the most basic polygon structure that you can look at. So to find the length of AB, I'm going to take the leg squared plus the leg squared and set that equal to the hypotenuse squared. Okay, so working this out like we did before, 64 is 8 squared. Okay, if I add those two together, I get 128. Okay, now as I look at my notes, I never went ahead and calculated out to the nearest tenths place. So I'm going to say it's going to be somewhere 11 point something. Okay, 11.3. I have no idea. But I would like to know this in simplest radical form. Well, where's the radical come into play? I'm going to undo my square with the square root. Okay, and now we have radical 128, or the square root of 128. Radical and square root are synonyms. They're the same thing. Okay, and so from there, I start to think to myself, what number goes into 128 evenly? Well, again, it's even, so I'm going to use the cheat method, divided by 2. 128 divided by 2 is 64. Okay, now from here, I know that 64, 8 times 8 is 64. So I could do this, and I could be done, because I know my answer is going to be 8 radical 2. Okay? But let's say you didn't recognize that 8 times 8 was 64. So let me work that out. Okay? So the 2 comes down. All right? What are the factors of 64? Well, I'm going to divide it by 2 because it's even. Now 64 divided by 2 is 32. Divide 32 by 2. Okay? And you get 16. Take 16 divided by 2. And you get 8. Divide 8 by 2. And you get 4. Divide 4 by 2. And you get 2. Okay, now I'm going to double check myself there because there's a lot of 2's there. And so here's how you do this. If you go ahead and take 2 times 2, that's 4, times 2, that's 8, times 2, that's 16, times 2, that's 32, times 2, that's 64, times 2, that's 128. I know I've done it correctly because the product of that is equal to what we originally started with. Okay? Now, I said every duplicate comes out from underneath the radical. Boom, out from underneath. Out from underneath. Out from underneath. Okay? Now, you may be asking yourselves, I've got a 2 here, I've got a 2 here, and I've got a 2 here. Do I add? Do I subtract? Do I multiply? Do I divide? Well, you're going to multiply them. Okay? They're multiplied underneath the radical. They're going to be multiplied when they come out from underneath the radical. So 2 times 2 is 4, times 2 is 8. So here's my 8. Here's my radical 2 that's left underneath the radical. And so as a result, 8 radical 2 there. Okay? Now the distance formula, it doesn't matter which one you make, x sub 1 and x sub 2. I know in the first example I made a x sub 2. Most of the time you probably make a x sub 1. So I'll just go ahead and make that x sub 1, y sub 1, x sub 2, y sub 2. Okay? So if I'm working out the distance formula here, let's see if I can have enough space to write like I'm in kindergarten over here. Real big letters. So distance, square root, okay. X sub 2 would be 3. That should be a minus, sorry about that. So 3 minus negative 5, that's x sub 1, squared, plus y sub 2 is negative 2, minus y sub 1, which was 6, squared. Okay, so working this out, okay, here we have the drunken plus sign again, double negative. So 3 plus 5 is equal to 8 squared. I'm feeling pretty good about that. Over here we have negative 8 squared. Remember, should we be scared of that negative? Not a chance. Okay. From there, 8 squared is 64. When I take negative 8 times negative 8, we get positive 64. And so the square root of 128 is what we're looking at there. And now we're back to where we were there. We've proven it's the exact same length. Okay, 8 radical 2. So, again, I appreciate your attentiveness. I feel bad that you had to try and read my manuscript, but hopefully I spoke clearly enough into the microphone. And when you come back on, let's see, on Tuesday, I will have probably some questions for you that deal with the distance formula and the Pythagorean theorem. And I'll expect you to be able to execute those. So Maybe a suggestion would be to rewatch this video right before you come back to school on Tuesday to make sure you're fully prepared. But again, I appreciate you doing this work here. In the long run, hopefully it'll allow us to be where we need to be when it comes to the end of course assessment. So thank you so much, and have a great day.